Hi, how are you doing?
I'm doing well. I'm just trying to get everything set it up.
How can I ask how do you say your name?
Oh, Gulem Bisat.
Gulam Basat. Okay,
Yeah. I
awesome.
mean,
Thank you.
yeah, no problem.
I didn't want to pronounce it wrong.
It's fine. It's been like that since preschool.
Yeah, so
So I can't. Yeah.
I have the same sentiment. I was given a Vietnamese name, and then they always butchered it in school, so I
Oh my
ended up
God. Yeah.
and then my parents when they I had to do my own citizenship because they didn't fill out the box in the 80s, and so
Oh no.
when I became a citizen at 18, I had to go and complete that on my own, and then I changed my name. So I kept my original name as my middle name, however, but yeah, it's I understand.
Yeah. I think it's
Welcome,
because.
everyone. Yeah. So what were you saying?
Oh no, it's just because I think it's because it's the whole people are not used to like the names anyways, and thankfully like now as as time is going forward and everything, like people are more like willing to learn like
Okay.
how to pronounce a name, so that's what I've came to a conclusion of, but I could be wrong.
Okay. Good. It's always good to learn a new name for me. I think it's always interesting to learn about culture and names. So thank you for sharing that with me. Yeah, I'm always interested in learning how to pronounce it correctly. So, all right, everyone, welcome back. We are gonna start in about a minute. I went through and I tried to troubleshoot so your Sonic Pi. So I had uninstall it, install it, uninstall it, and install it. So I rewrote the instructions. So hopefully you won't have some difficulties with Sonic Pi. But if you run across difficulty on Raspberry Pi, you can always install it on your Windows PC or your Mac OS. It only works with some Linux versions, like the Debian base, Ubuntu. Um, so it's not browser based, it's an application. So if you get a chance, take a look at the lab and I'll walk you through it. Okay. And we're going to make some music to start today. So if you have headphones or a speaker, you can attach your speaker to your Raspberry Pi so you can hear it. Or if you're using a, a pair of headphones, if you have the old ones where you plug it in, you can. Or if you have the Bluetooth one, I actually wrote down the instructions for you how to install Bluetooth. It doesn't, even though Bluetooth is there, you have to bring in Bluetooth audio because Linux is like that. You have to bring in various packages. Okay. All right. We're going to go ahead and get started. Do you have any questions for me before we start? We are going to do 2 exercises today. So you have an option of 2 out of 4. You can do the one that I'm doing, or you can choose to do other ones. So we're going to do the last 2 tomorrow. That's going to be Minecraft and the GUI. So today we are going to do Sonic Pi, and we are going to do a simple local web server. It's not going to be connected to a cloud server yet, but you can if you do have that type of service, okay? Or you can acquire services with your internet service provider so it can bring in your DNS traffic. Okay, so I'm gonna go ahead and start with the screen share for the instruction, and then I'll flip back and forth on the Pi, and then we'll go from there. I'm gonna, um, okay, so we are gonna work on, I don't know why, sorry. I actually clicked stop share there. Um, we are going to work on our exercises today, and we're going to start with Sonic Pi. like I said, if you just join, we are going to have the option to do two out of the total four exercises. And I only gonna need you to take either the screenshot of the picture of what you have completed. So Sonic Pi is near and dear to me. I think it's really cool that you're able to program your music and create your own synth, or use your built-in synthesizer that comes with Sonic Pi. So if you visit the site, which I included the link here, um, you will find some information, but let me also open up my 1 second. Sorry about that. I did a PowerPoint, so look, it's short. Okay. If you visit the site, you're gonna get the general information on Sonic Pi. Um, and so, okay, all right. So this is a way that we can program our music using an application. So just to give you a little bit of background, um, the application itself was created by Dr. Sam Aaron and some of his team members. And he teamed up with people from University of Cambridge Computer Lab, and they collaborated with Raspberry Pi Foundation up until the latest release. Um, so the source code for this application is available, but if you want to use his application, you should contact him and ask permission. And that's pretty much in general for open source code. Okay, so if you want to rewrite the application, so up until recently, for the version that came with your Buster operating system, which is the operating system that we're using on your Raspberry Pi, um, Raspberry Pi team or the foundation had decided that they are going to write their own application or updated the Sonic Pi application. And so the version 3.1 that was originally installed was not complete. So when you launch the application, you would probably get a server error. And so the version 2.2 came, and also Dr. Aaron had gone back and rewrote his own the updates for it. And then they finally got some of the fixes. So when you're looking at the earlier version compared to our current version, the installation file is slightly different. Um, and so the in a few months ago, they actually released 3.3.1, which is somewhat stable and it's working. You do have some variations of, people posting on the actual website itself, saying that some of the things are failing and so on. So Sonic Pi is not 100% perfect. Just keep in mind it is slower, especially if you have lower amount of RAM. So if your computer, if you're running it on PC, and if you just have, let's say, like 6 gigs of RAM, and the majority of the RAM, 4 gigs, already used for your OS, you tend to find that when you start working through Sonic Pi, building your songs and your tracks, you're gonna see that it's gonna slow down. On the Raspberry Pi, if you're using Pi 4, right, like that's what we're using, with the 2 gig of RAM, it's going to be okay. But if you have 4 gigs of RAM or higher, that will be a better choice for system for the application. So it's really written in Ruby, and the information that's given to you on the website, they call it Kids Ruby. It's just the interface is more younger age friendly. I really think that Sonic Pi can be used in all age. It's really fun. And it's a good way to really learn about music and also programming. And you do have some sample and example that's used. So I'll talk a little bit more about the help option in it. If you visit some of the tutorial or the resources on the website, there are teachers and people post lessons and things that you can use. So if you are really into music, you can try out those tutorials. They also made videos, so you can check out some of the video on the website and of course YouTube. So the application itself is really available in Raspbian, in Mac OS, in Windows, and in some version of Linux. And you can visit the website to find out more information and also download the appropriate or the application for appropriate OS. For Ruby, just to give you a little bit of background on Ruby, it's going to look very similar to Python, but Ruby uses a compiler. So it will compile your entire code before it runs it, and you would use Sonic Pi application to write your code and run your code. So itself, Sonic Pi, it is an IDE. It's a way for you to write your scripting language and then to be able to test it at the same time. It doesn't necessarily mean that you cannot make your own synthesizer. You can bring in external sound and things like that, just like how we would bring in libraries or files in other languages. So for Ruby, it is open source. It was created by Mats, or he's known as Mats, but it's Matsumoto, in 1995. And when you look at the language itself, it's really a blend of multiple languages, and it's really his favorite languages that he learned or he used. And so he combined it to make it a little bit more, he called it elegant or more friendly to use. And so Ruby, the name came from the birthstone, and it was just from one of his friends. And it is object oriented and it is easy to use. It's a scripting language. So what you see is you see Ruby being used quite a bit in applications, and it is different than Ruby on Rails, which is used for web development. So some people, if they don't know, they would mix it up, but it's really good to also learn an additional language. And you're going to see that it's similar to C and Python, or it is C based in general. Okay. And this language was really widely accepted in the early 2000 or the mid 2000, and it really is part of the top 10 language to learn worldwide. So if you want to really get into programming and development, this is another good language to pick up. And you're going to see the syntax and the form is going to be very close to what you see with Python. And so you would have something similar with the loops. But keep in mind that when you work with Ruby today, space and symbols like comma, colon, semicolon, they're very important. Um, so, if it's not detecting the IDE, if it's not seeing something that's supposed to be there as far as syntax, it's going to throw an error and it won't run your code. So, what you want is you want to really pay attention to how you type today. Like typo would cause an error, and so you wanted to take the time to take a look at it and troubleshoot in case you do. Okay. And then indentation is also important in the syntax. So when it needs to be indented, you have to indent it. It's not like C or C++ where it's a little bit more forgiving. So indentation is important, especially in the body of a loop, like what we've seen in Python for loop and while loop. So for the software, as far as development, I mentioned that Ruby on Rails. Ruby on Rails is really a web framework, and we'll touch on web framework when we talk about Flask in the second activity. But you would see if you want to get into more web development, you have to be more comfortable using web framework like Flask, Django, Ruby on Rails, and so on. There are many, but you want to focus on the top 10 or the top 5. Those are recommended. And so the bytecode instructions is used to compile. So when after you write your code, it's going to break it down to the bytecode instructions at the low level. And very similar to Java, it uses a virtual machine to really be able to execute your code. So And this is called YARV, or yet another Ruby virtual machine. And you see object-oriented languages use virtual machine like this way, in, when in order to compile and execute your program. So Kids Ruby is just another term that is incorporated with the Ruby language. It's made to really easy to enter the code or the script, and also use an interpreter that's simple, and you can also build in the library. So Dr. Sam Aaron had incorporated a lot of the sound library for you to use. And when you update this a few months from now, you're going to see that there are also additional things that will be added. And that's what's really cool about open source application, is that the community can really um, add to it, or use it in a way for educational purposes, for nonprofit purposes. Okay, so some of the things that we wanted to kind of learn for the basic today. When you see synth, that's just sound from a certain musical instrument like piano, drums, vinyl scratch. Like if you wanted to add some vinyl scratch, we're going to do that today. So when you see synth, that just represents musical instrument sound. And then you have amp, that's going to allow you to change the loudness or the volume of the sound. So if you start with a numerical value like 1, that's going to be your average normal sound. But if you wanted to make some sound louder than the other, when you mix the sound together, you want to increase that value to a higher value, right? Like I can put 2 for a certain sound, 3 for the piano sound. So to make it really highlight it in the compilation of your sound. And then you're going to see something like nil, which is a silent beat, where if you listen to a song, there sometime would be a pause where there's nothing that's going to be played, no instruments, or no singing, etc. So we want to incorporate something like nil, so that way we can have some form of beats, because we can make something that will be rapid, pause, and then add some additional sound to it. And so for the sleep, that will be the time in between the iterations. So let's say that I would have a loop, and I wanted to have a pause in between my loop before it circle back to maybe play the sound for the chorus. What I can do is I can have the sleep added, and so you would see sleep in your script today. Um, and then you will see that we will use some of the example where we would have notes. So just like if you learn music, right, you would learn different notes. And when you did the piano, if you took the Arduino class and you did the piano with the Arduino, you saw that you can play like A, B, C, and so on. So you can play a note or a chord using a certain synth like piano. You can play F, you can play E, etc. Okay. And then you also see play pattern time. So you can play certain notes for a period of time. So what it is it is an embedded loop inside. So it would keep looping for the number of time that you would specify. And you can make it long or you can make it short. It's really up to you. Okay. And then if you want to send the loops, so let's say that I wanted to loop something 5 times, then I would put 5 dot times do. And the do loop is just going to keep going, kind of like the while in what we've seen in Python. So we can loop a certain thing a number of times by specifying the value in front of the dot times do. And when we start today, we're going to do a live loop with the flibbo do. And so basically we can give it a name and for our loop. So this is a continuous loop, and the way that we chose to name it is going to be flibble. You can give an identification to a loop. And so, but the important thing that I wanted to note here is that you should never have multiple live loops running at the same time. you need to make sure that one ends before the other one kicks in. It's going to cause the error. It's going to tell you that it can't do it. So if you want to run live loops, you need to make sure that they are sequential, not concurrent. Okay. And then always, except for in the case where we sleep at the end, but in our script, when you finish the song or the track, you wanted to give it a keyword end. That means it's going to end all the function. So that way it would release the resources back to your system. Very similar to what you see in return zero for C or C++, right? So we wanted to stop everything or end at the end of our song. And then if you just wanted to output string for fun, right, it's going to show on the right hand side, and you can put text as string into quotation marks, double quotation marks. And so that way, while it's playing your sound, it's also displaying on the right, the output. So that way you can see the flow of your script for your song. And then for the sample with the parameter, you can incorporate pre-recorded sound sample. So when you see sample, that's really coming from their library, but you can also include sample from the outside. But at the top, just like all languages, if we're bringing in external components to our script, we have to make sure that we tell it where it's going to find it. And usually you have to store it in the same directory, the folder. It's just a way that we organize it so it can quickly map to that file and be able to pull the content of that file. So the sample that we're going to be using today, there are various sample. So I'm only going to give you some exposure today, and I encourage you, if you like this, you can continue and play with it and learn more about it. Okay. So and so let's make some music. Okay. So for our lab, we are going to use Sonic Pi. And in Sonic Pi, I have a feeling that Zoom is going to use the service. So um, let me join from the Sonic Pi side. So in order for Sonic Pi to work, you should uninstall the current version, which is version 3.1 that came with your Raspberry Pi OS, and then install your version 3.3.1. Okay, so all you're gonna need for today exercise is you're gonna need your Raspberry Pi with the power cable, and you can plug that in and boot it up. Like I said, if you have a pair of headphones or if you have a spare speaker, you can connect to the Raspberry Pi so you can hear. Otherwise, it won't do you any good to really code it and not hear your music. And then you need to use your Sonic Pi. So on the interface, okay, let me share screen. I I took a picture of that and show you where everything is, but I'm gonna walk you through it, and then I'll walk you through on how to uninstall and install the new version. Okay. Let's allow. Okay. All right. So let me unshare this. Sorry, let me turn this off in case you get echo. I'm using my Bluetooth speaker. Okay. So here is your Sonic Pi. And what you have, the functionality at the top is going to give you, preference control, audio, how you want it to sound, your code if you wanted to save it, but it automatically saves it to individual tracks right here. But if you wanted to save it to a certain file name, you can. And then also, it also has the save buttons up here. If you wanted to record that, you can also have the record button. And after you finish your script, you can run it, or if you need to stop it. Now, if you have any kind of error, it's gonna show it's gonna show underneath here where it's gonna highlight that in pink, and it's gonna tell you the line where you need to go to fix your error. Okay, so if you have multiple error, it's only going to catch it one at a time. So after you fix that error, you run it, and then if it has another error, it's going to tell you again. So read the message in the IDE in Sonic Pi if you come across error. Like if you trying to play your script or your code and you don't hear anything, you need to check your error. Then so there's the interface, and this is what we call the text editor part of the IDE, where you would enter your script. When you run your code, you're gonna see, it's gonna show you the line that's queuing and it's running here. If you have text like our Pi rocks, it's gonna show on the right. And then if you wanted to change the size of the display, you can increase the text size, and you can decrease the text size. So that will allow you to change it up if you like. Okay. And then there's also help options up here, information. And then if you wanted to take a look at like how it would be in audio waves, you can toggle that. Okay. So you can click on it, and then for the preference, you can change up your preference. Um, Now on the bottom, you're gonna see that there are tutorials, examples, synths, FX samples. So if you're looking for a certain sound sample, you can look at that here. If you wanted to take a look at certain example, you can also click the example button, and it will take you there. Okay. And then if you prefer for Sonic Pi to show you in a different language, I think they incorporated other languages on here. So you can choose language and choose your language option. Um, so there you go. So this is the interface for Sonic Pi, and it is a little bit slower to load to start. So that's what you would see. Okay, any question with this? Okay, so I'm gonna go ahead and stop share here, and then I'll switch over to the next one. So to start, what we will do is first, we want to make sure that we have the right version. Otherwise, it's going to be it's going to crash. So you want to have version 3.3.1. And on your Raspberry Pi, you want to open up the terminal, and you need to purge, you need to uninstall the version that's already on there, which is 3.1. It's an older version. Okay. So, all right. So for the Raspberry Pi, let's expand this. You can start with going in, and you would do sudo, right? Follow the instructions, and it's going to tell you to do sudo apt get purge Sonic Pi dash pi. Okay. And then after, when you execute that, it's going to take a minute or so just to uninstall the Sonic Pi, the version 3.1. and I'm not going to execute that because I already have stuff saved on my Sonic Pi. Then what you're going to do after that, after it's installed, is you are going to open up Chromium, which is your browser on the Sonic Pi, and you are going to download. Okay. Why are we not doing it in terminal? Because you can do it from the terminal. You just got to do a wget command and you got to pull it from, or you can, if you have the git install already, like what we learned in the prior days, you can pull it from the GitHub, but you have to specify the specific, the version number correctly. Otherwise, it's not going to be able to pull it. So um, just to kind of minimize some of the additional longer instructions, I just wrote down that you can use your interface to be able to download. Okay. So after you have written out your your command to be able to uninstall, then you're going to open up Chromium. You would see a little globe, and that's going to open up your browser. Okay. And then you would need to go to the GitHub, or you can search for it. Okay, so download Sonic Pi version 3.3.1. Oops. Right now, I think they're betaing some of the next version. I also put the link on your document for that. Okay. And so if you search for it, it's gonna navigate through and it's just gonna give you the result, and it uses DuckDuckGo. I don't know if you're familiar with DuckDuckGo. They when you use DuckDuckGo, you're not exposing yourself to a lot of the things that they track. Um, so you can, they are a privacy company. They always advertise that. So you can go to this right here, or you can use the GitHub. Okay. And then on the sonicpi.net, sorry, my Raspberry Pi is a little slow because it's running a lot of different applications right now. So, and I'm also screen sharing. So if you scroll down, you would see different buttons. So for the Raspbian, you would click the Raspberry Pi OS, and then it's going to take a minute or so to download. Okay. And if you wanted to do this on Windows or Mac OS, you can also, you can download those on your systems. So once you have it downloaded, you would find it in the downloads folder. Okay. So I had tested I had tested version 3.2.24. They said that that was somewhat of a stable version, but I still ran into some issues. One of the things I want to mention is after you install the application by double clicking it, you need to reboot your Raspberry Pi. It doesn't take effect until you reboot, because if you don't reboot when you're trying to run the application, likely that you are going to get the same error message. I had tested this numerous times, um, in the last few days, just to make sure everything works for you. So that will be, so once you downloaded the file, it should be in your downloads folder under Pi Home. And then you would just double click it, and it will then go through the installation process. And then after you install, you just need to reboot. So you can go to the Raspberry Pi button and then click log out, restart, or reboot, or you can type in reboot command in your terminal and it will restart. Okay, so let's take a minute or two to get all of that set up. Any question while we take time to install this? So one of the things that I have added also is for Bluetooth audio device. Even though the Bluetooth option is next to your Wi-Fi button at the top right, you're gonna find out that if you have Bluetooth audio devices or Bluetooth devices and you're trying to connect to it, um, it might not know what you're trying to do. It will connect to it, but it won't be able you won't be able to operate it, especially for the audio. So I have a little Bluetooth speaker that I bought a while ago, and I wanted to use it to play um, music. So I would then need to turn it on after I configure it. So in Raspberry Pi, you have to install ALSA Bluetooth. I'm sorry, uninstall ALSA Bluetooth. Um, if it's not there, it will say that you can't purge it. That's fine, just in case that you have it already installed. Then in the older operating system, ALSA is actually already incorporated. I think in the later version of Raspbian, they remove ALSA. I've used ALSA quite a bit for, voice and for microphone and speaker option. But what you want is you want Pulse Audio, and so when you install Pulse Audio module, it will bring in the library that will work with your Bluetooth devices for audio. So in Terminal, you first have to update and upgrade automatically, right? That takes about a minute. Then you would then uninstall Bluetooth ALSA, and then you would, after you do that, because if you don't, if it's there, it's going to cause conflict with your Pulse Audio and it will not work. And then after that, you would use this command to install Pulse Audio. And then you're not done there, right? So after that, you would then need to make sure that you have the user privilege to access that, because in the Linux system you got to make sure that you have the proper uh, group and user um, access. So it's gonna have you do user mod, so you're gonna be able to modify and then add yourself to the user group for add pi, which is your current user, to the user group for Bluetooth Pi. Okay. So everything in Raspberry Pi is its own entity, right? Like we talked about Sonic Pi right now. You are going to use Minecraft Pi, which is an application, but it is itself. So in order to access it, you have to be part of that particular application. So then after that, you would then reboot. Okay, so for these, anything that you install that's going to impact the system and the user, you normally would then have to restart. Okay, so after you would add all the Bluetooth, if you have Bluetooth, then you would take your device and you would turn it on. I hope I'm not going to get echo. And then it will be blinking blue on your device, and then you just need to make sure that you pair it. So on here I have it already paired, so if you don't have it paired, you would then need to pair it. So it tells you that you need to add the device, and then you would need to choose the device that you're trying to add and pair it. Very similar to what if you're pairing your headphones to your phone, right? But after that, when you're finished, you would need to right click your speaker option and then choose the appropriate speaker. Okay. If you are connecting, the old school headphones that goes to the AV jack, you would need to select that. Okay. Or if you're using like an HDMI connection for your speaker. Like if you have a subwoofer with a speaker and you connect it with HDMI, you need to make sure that you select that. So it doesn't automatically put it there, right? Like what you see in Windows or Mac OS, you have to tell it what to do. So the user has a lot of the control in what kind of devices needs to be on, paired, connected, and be used. Okay. Any question? Okay, so that gives you a little bit of information on how you would connect your Bluetooth. So I'll give you a couple minutes to get everything set up, and so that way we can start programming. And the script that's given to you, you can play with it, you can modify it, you can add more sound to it. Like I said, you know, when I did this, I just wanted to make sure that you get some of the basics so you can start building it up from there. So when I did this with some of the younger students long ago, right, we did it several times in some cyber camp. Um, One of the students, well, one group at the end when they did the programming challenge, they actually created their own song and then they used the sound of it to be added to their thing that they wanted to play, plug a speaker in. So they built like a little circuit that blinks to the sound of the song. And it was pretty impressive for a group of girls who are 11 years old that just learned programming for 2 days. So I was super impressed with that. They're very creative and they're very, they were very fast to catch on to some of these things. And so, yeah, they won the award that I was giving away for the cyber camp. So I like to do these for little kids so they can learn programming and have fun at the same time. Okay, the next part we're going to talk about is the first part of our program. Okay, so once you have your Sonic Pi installed, you're going to open it up. And as I mentioned before, each of these are, think of it like storage space, starting with 0 and it's going to go up to 9. Okay, and then you can also go file save, or I'm sorry, click the save button, right, or the option up there to save. But if you don't, it automatically saves it for you. So each of these are going to be different code for different songs. So on this one, we're going to start with something that would be just 60 beats per minute. So when you start your song, you should always have a statement on how many beats per minute that you want to use. Okay, you should, but you don't have to. Um, but it's a good way to really kind of look at how you want to build your rhythm in the song. And earlier we mentioned that we can name our loop and we're going to have one life loop. Okay. So that means that it's always going to keep going. Okay. And you can also do fade out on a loop and then bring in another loop if you like. Sorry, my speaker just went to sleep. Um, so then we would have a loop called flibble, and it's gonna do, so it's gonna keep running. And then underneath that, this is the body of your loop. So you have to indent it. Okay. Make sure that we have the comma, the colon appropriately. Otherwise, it's not gonna run. Okay, so we are going to use a sample, and we are going to use a sample called BD House. So if you want other samples, you can check out other samples down here. Okay, it will give you information, more information about other sample. And then for the loudness or the volume of it, we are going to keep it at 2. So it's going to be a little bit above normal. Okay. And then while it's running, it's going to print out the text, our Pi rocks, and you can put your name, you can put anything you want there. And then we are going to wait in between the loop for a quarter of a second. Okay, let's try. Okay, so I'm gonna first input this in, and what I like for you after you input that in, run it, and if you're successful, it's gonna play sound. If there's error, you need to fix the error. So after we enter the code, we would then click run. Okay. I need for chat to reach. Okay. And then see if you hear something. Oh, I'm getting an error. Let me see. Live loop flibble. The thread too far behind. Sorry, I have extra indentation. So let me fix. It should indent though. Yep. Let me fix the indentation on this. I tested it earlier and it was fine. There's some extra space with sleep. I didn't like that. So as you can see, and if you copy and paste the code, just remember that the symbols don't interpret sometimes, and also space don't interpret sometimes coming from Microsoft Office into the application. So that might run into issues. So I recommend that you type it. Okay. So you should hear like rapid beats, just mostly drums. And you can stop it if you don't want it to run anymore. And as you can see on the right, it shows your text, and then it shows you how many lines that's ran, and so on. Now on Sonic Pi, it uses what's called the Super Collider audio server, and this was built by Dr. Sam Aaron. He incorporated this, and you know, this is a major component in how the application will be able to take your code, and I'll put that in the sound. So okay, so after we have that, we can also add in more. Okay, so we would add the second part to it. Okay, let me stop share on this side. Let's switch real quick. I see a chat question. So you will have more sound to the actual song itself. And then what we're going to do is we are going to do next is we are going to add the second piece. Okay. So what you want to do is you're going to take this part right here, okay? And then you're going to add it after the first sleep before the end. Do not put it after the end, otherwise it's going to run into an error again, okay? So you're going to type in the next sample. So make sure that we indent in for the next sample, but put it after the sleep and before the end. Okay, just 2 lines. And then you're going to click run again. So the whole thing about layering sound is to see how it sounds like, and if you don't like it, you can change up your sample. I don't know if you ever use like software to mix music, right? You would then play with, you can bring in your sample, you can create your own sample, and be able to do that. Okay, so then what we're going to do next is we are going to stop share here, switch over. And so I'm going to share so you can see. Okay. I think it just got disconnected on that side. Let's reload you. Sorry, I just got rooted out of my own Raspberry Pi here. Okay, we're back. Okay, share screen. Okay. So on the next part, what we're going to do is we're going to type in sample, right? And you can see a list of sample dropping down here. And following sample, you wanted to have the space and then the colon, and then do part snap. This is a built-in sound or the built-in synth. And then we want this amp to be 1, which is going to be less than the other one. And after that, we're going to have it sleep for another 0.25 seconds. Okay, so once we have that, we can run it again. Sorry, it's a little staticky on my end. So now you would hear the drum and then the finger snap or the perk snap. Then what we're going to do is we're going to layer it again, and we are going to add in more sample. Okay, so after we had done that, then we can do sample again. Okay, and then in this one we are going to put in the dub. Make sure that we add the comma for the parameter, and then for every synth that you're adding, got to make sure that you tell it how loud or how loud you want it to be. Okay, if you want something to stand out more, you can increase the value. Okay, and then after each sample, we want to just make it sleep. 0.25, and then the N is going to follow that. So then we can run it. Oh, I have the syntax here. Oh, yeah, it didn't see my, like I said, space. There we go. So make sure that you see the sample in pink, right? It should highlight that in pink for you. If it's still in black uh, text or gray text, that means that it didn't recognize it. So, and because I added an extra space after the colon and it didn't like that. Okay. And then after we add the dub, we would then add the second snap and so on. So we just keep laying the sound until we get something that we like. Okay. Perk. Oh, here I did it again. Snap 2. And it's gonna be 1 on this one. And we're gonna have it sleep again for 0.25 seconds. Okay, once we have that, we would run it. So if you wanted to increase the BPM, you can make it faster, slower, however you want it. If you want to slow it down, you just bring down the value. If you wanted to make it faster, you can change it up to like 80, 100. It's going to be a little bit more rapid when you hear that, right? So we already have the drums and the snaps layered. Then we're going to add some instruments and we can add some additional sample. So then in the next part, what we're going to do is after the perk snap 2, and this is, I'm at step K, L, and M. So we're going to go ahead and do sample. We are going to do a vinyl scratch. And you can select it if you don't want to type it. My thing is a little slow with everything running here. Okay. And then you are going to have the amp a little lower on this one. And then we also need to sample another loop, the loop. And we're going to add some Safari sound. Okay. So before I add more, I wanted to test it again. And then, so we would then add more to it, as you can see. So you can do ping, bells, all kinds, once you identify the ones. But if you follow along, you're going to see that, you know, it would then have more of a compilation of different sound that makes a little bit of sense. Sometimes when you throw something in there that doesn't belong in there, you're going to hear that it's going to sound kind of weird. And then so you can take that out. Or a way that you can do that is you can comment out. So very similar to Python, you can use the hashtag. So do a shift 3. You can comment that out if you don't want, you want to test it without that sound. Okay. So I have the complete. I'm trying to, okay. And as you notice that I comment out one of the loops here, right? And then you can test it with it, you can test it without. So I have basically the sample added, and then the synth here, I'm going to use the piano, and instead of having it play notes, it's just going to have the pre-recorded instrument sound for the piano. And then for the notes, I would specify 52, so you can put in the notes that you want to play. Okay. And then for this, you can add in release, and you can also, so when you add each line, you can play it, you can hear the difference. So that way you would know, oh, okay, um, I might need to increase the volume on this one, or I can change the rate for the loop to make it faster. So you can hear, I would have the rate of 2, and then how you want it to be released, or if you want to put it on sustain, you can add in the values, you can play with it there. So let me run this. So then we can still add more to it if you want. You can add some additional sound, but you would get the idea that um, how you would have that. Okay. Any question? Okay. So one of the things that we can do is, what if you don't want it to go on forever, right? What if you want to make it run a few times? So step O, P, and Q show you how you can do it for 4 times. So I'm going to go ahead and replace this, okay, with the 4 dot times do. So I'm going to comment this out. And then I can type in but we're going to make sure that we tap these guys in. Oops. Because it's part of that loop. So it's like implementing the for loop, if you're familiar with for loop, and make it run, iterate 4 times. Okay. Okay. So you can replace, take out that line and type in 4 times do. Just make sure the body of it, you wanted to indent it. Otherwise, it's going to tell you error. Is there a library for different sounds? I'm sorry, it doesn't. What does flibble mean and what type of sound? So flibble is just a name of your loop. So a live loop, you can give it a name. So like I can call it live loop Cynthia do, and and then I can add in the body of it. So it's just a way that we can name it, because you might have many different loops. So what happens with that is it's going to create a buffer location that's going to be used for that loop in your memory. Yeah, kind of like a variable, or like an array sort of, or a list, right? And in that list, like if you're familiar with Python, you would have different sound and different instruments, and each sound would have its own volume, and wait time, and so on. So flipple is just a name that we can use. You can call it, something else, but you just got to make sure that it's live underscore loop colon, and then the name of it, and then do is, it's a continuous loop, it's an infinite loop, so it never ends. Okay. And is there a library for it? There are people who have written sound library for Sonic. Um, and remember that this is in Ruby, so it has to work with Sonic Pi. But yes, there is library that's built into this already. There's built in that's what you've been using. And then I've seen that people when we look at the other sample, you're gonna see that we will see there's some stuff that we can bring in externally. So you can. Okay. All right, so that's the main exercise where you can add in different sample. You know, the cool thing about this too is if you are in, if you're musically inclined, if you play, the MIDI keyboard, I don't know if you use it, um, but let's say you have a keyboard and you wanted to make your own sound, or if you have some kind of instrument that you wanted to record your own sound, you can create a file, and as long as you, just like how any other module, right, when you bring in the module, you got to tell it what name of the file it is, and you got to make sure that it's locally stored in the same area. So there are tutorial information on how you can incorporate external samples and sound and files and things like that. Um, and then if you watch the video, some of the musicians, they use Sonic Pi, like Daft Punk. Some of the artists, they use this tool, and it's just elevated that we can code it. Okay. All right. Any question with the first part? Okay. So I'm gonna stop. Let me open up my Sonic Pi on my Windows so you can also see. And it's always, up in the air when you go into Zoom and screen share and run Sonic Pi at the same time and doing other things. It's not always okay. So I'm gonna stop share on this. So what you can do is you can add in another song. And so I also have Tetris on there, but it plays a little choppy on the Tetris end. Okay. Does the sleep function pause the beat? So you can use nil is a silent beat to pause in between beat, or you just sleep is you let so the sample you wanted to run it, and then it's like a wait in between when before it runs again. So when we say like sample perk snap and then sleep for a quarter of a second, so because as it continuously loop, it's infinite loop, in between its play again, it's gonna wait. So you do hear silent, but it's not a silent beat. Yeah, so it is a pause, or before it runs again. Okay. Yeah, think of it like a wait. And you can be very creative with this. It's really fun. I feel like it's fun because I love music, and and I like programming too, so it's like two things that I love and in one. So all right, on the next one I will show you the Tetris is one of the common one, and this is actually somebody else's script, but it's simple enough. I massage it a little bit, but so you can hear the Tetris, and you can use different ones, but I wanted to run through the code and show you what it is. Okay, so you know what it is. Okay, so sometimes when you're using synth, you know, um, your program sometimes would want the IDE is going to want to debug, and that just takes up more resources and it reduces the performance. As you know that Sonic Pi, when you have a lot of stuff running, it's gonna be a little slow already. So so at the top, if you wanted to kind of avoid the debug part of it because it does do the debug in the background, then you can do the use debug is false. Kind of turn that off. And then, like the other one, we would want to specify the beats per minute at the top. And on average, that's what you would see in most songs is 60 beats per minute. But when you hear something a little bit faster, like EDM or, or it could be, or something slower, if you wanted to make like a country song that might be a little bit slower, then you would want to then reduce your beats per minute. So this one, we actually use a variable and we would say that this is the variable that's going to hold 60, and then we are going to specify 60 beats per minute when we get to the body of it here, right? So then we also use a list to put in the type of sample that we want to use or the synth that we want to use. So if you want certain synth, which is your musical instrument like piano and that exists in Sonic Pi already, you can group it or you can use them individually like what you've seen. Okay, so your synth is going to go into a list, and then we are going to loop it 5 times. So think of it like there's only a do loop on this one, right, for Sonic Pi. So we're going to run it 5 times. And use BPM is a built-in function. Think of it like a command to tell the system. So, and then you're going to plug in 60, which you had declared at the top. So here, what we want is we want to use 60 beats per minute, and that's come from this variable. And then we are going to have use another function called use synth, and then we are going to bring down the group of synths that we specify. Okay, and then for the put, this is the same thing as print, so it's going to display your text. So in Ruby, technically you just use put, but print also works with it because it understands the print function or method, right? So you want to output text playing Tetris. And then for the notes that you want to specify, then you would then group them together. So for the whole song, you can put the compilation for the whole song with the notes. So here we would have a list of your notes or an array of your notes, right? And then for each one, as it's going to iterate through it, in between, we wanted some kind of pause, right? Because we just don't want a long note. So we can specify like how long we wanted to play it, how long we wanted to wait in between the loops. Okay, and then you can also increase your speed. So in the second part, as it loops, so the second round, it's going to be 70 beats per minute and then 80 beats per minute and so on until it ends, right? Um, and so it's going to tell you what kind of speed, how many beats per minute. So if you want to increase and decrease, so here we increase by using compound assignment operator by doing a plus equal. So we can increase the speed each time by 10 beats per minute. But if you want to decrease, like slow it down, you would use a minus sign or, a minus symbol there. And then you can output the beats. Okay, if you wanted to make it slower, do a minus. Okay, any question? Let me reshare. I think I previewed this yesterday, so. Oh, yeah, I'm connecting to the other one, but you can play it and it should play like bell sounds for Tetris. Second, let me reconfigure my. Any questions while you go through that? Okay. Okay. So there are variations of songs that uh you can use in the exercise. Okay. We got the Tetris song, and then if you want to try something a little longer, you can do the La Cucaracha song. Okay. So on the La Cucaracha song, you would see that it is faster. Okay. Like this one. It's gonna be 120 beat per minute, right? And it's using different synth. And then for the release, we can just name it. Okay, so the way that you specify it. So for the synth default release, we can name it as the Cortea. Okay, so just use that every time. And this originally is so you have 1 and 2. So you can use variable, and then you can bring down the variable inside your script or your code. Okay, so it's gonna play some notes and it's gonna wait, right? Um, and then it's gonna go through and it's gonna play the whole song. Okay, so let's share that so you can see. Oh, I'm getting runtime error again. Yeah, I don't like this one. Oops. Yeah, if it's too far behind on the thread, it would not run it. So, so that was the pretty bell. That was the first loop, and then the second loop is gonna do the D pulse, but faster. And then the third loop is gonna do the piano and then faster. Okay. Okay, so you don't have to do all of the songs in the in this particular exercise, but I like for you to do a couple so you can have an experience with using Sonic Pi, right? You can take a look at how, it's coded. The longest one is the Star Wars one. That's the one at the end. And you can see that, like, there are a lot more instruments that's involved in that one. So in that one, you would use a lot of the additional. So there's also hook, and then you can also change it up with how you want it to sleep. Okay. And then you can group up the notes. So it's a little bit more complex. So I wanted to include it so you can see. And there are a lot of different resources online that you can take a look at. So you can practice on how to add in chords and things like that. Okay. and it does do the return statement. Um, if you wanted to have a function that's built for it. Okay. Any question? Okay, so play with Sonic Pi. You just need one picture once you finish with the song, or you can make your own, or you can use the one that I provided as example. The first exercise will be good too, or any of the other ones. Okay. Okay. Yeah, I feel a slowdown on my side sometimes too. It's because, um, it's the afternoon. Sometimes it does get a little, busy. So my network sometimes is slow, and then when I'm running Sonic Pi on the Raspberry Pi, it's a little slow too. Okay, so it's fine. I will share the video in case some of you get cut off or anything like that. Any question before we proceed to the next part or exercise 2? Okay, so um, okay, so the examples you see there, okay, and then after the Sonic Pi, you would see your web server option, which is assignment exercise 2. Okay, so I have about close to an hour to finish the second exercise. So I just wanted to walk you through and talk about it so that way you can, if you're ever curious about setting up your Raspberry Pi as a server, right? Um, you can for minimal stuff, but you know that when you have web pages on there, and if people are visiting it, you get a lot of traffic. Your Pi is gonna, it's slow. It's just a small system, so usually it should be used with a better server system. But I want to show you how you can do that. Okay, so in exercise 2, you're gonna have a little bit of Python, a little bit of HTML, a little bit of CSS, and it's, you're just gonna make very basic. There's nothing fancy that's gonna go into it. So for Flask is what we would use, and this is what's known as the micro framework. This allow us to really integrate libraries, database, and especially when you're working with API um, for application interface. So something that would be like, let's say that I want my my login for my user to use Google login or Facebook, right? You ever log into a website or an application using, your Google account or your Facebook or your Instagram account, whatnot. So I need to use a framework in order to tie all of that in, instead of just, hard coding a lot of stuff because it's already pre-built. So we can use it for open authentication technologies. We can use it to build database with our applications. If you wanted, like, let's say I wanted a server for people to download or upload files, it will also help me in, setting up how my files it's going to be uploaded, and then we can have it where that file is going to go. So there are a lot of different areas in the web application that we can use. And Flask is the micro framework. So if you click the link there, it's going to take you to Flask documentation, and there are tutorials and resources. It's really helpful if you wanted to look further, like how to use MySQL or SQL Alchemy with MySQL, with Python, right? To make an application that uses database. There's tutorial and projects that you can use. So here we are going to implement some advanced patterns. We can use SQL Alchemy, and it would be used for database, for non-relational data persistence, or relational. And with SQL Alchemy, you don't have to use it with MySQL. You can use it with other SQL product. And SQL basically is a language structure for database, right? And so this is a good light framework that we can use for the purpose of our exercise. Okay. So if you visit Flask, it also talks about decorator, which is what we see today. And Flask works really well with Python. So when you look at jobs that would relate to Python development or web development with Python, most of the time that they would want you to know some kind of web framework. Django is a common one. Flask is another one, right? You would see different type of framework that would be required for the job, but so Flask is is good with Python. And then you're gonna see that you would use uh, the decorator. Okay, so the decorator, um, similar to what you have seen in other form of decorator, you would use the at symbol to indicate that it is a decorator. Decorator can be used to for pattern recognition in other form, but in this one, this is an example of how you can have a required for login for the decorator, and here you would use the wrap with that. So without going really advanced into this, for your web server, you would name your web app very similar to this. That's like a common practice with for basic development. So you would bring down the object name here, and then you might use something like route to make sure that you can use that decorator to really set it for that particular page. So you can bring it to that page. You can also use it with just a slash symbol, or if there's a certain page that you wanted to say like my page or my profile, you can add that there. Okay. And then here it's also used with login required. So when the user visit that page, what's going to happen is they're going to get prompted with the login. And then with that, we can incorporate functions in order to really authenticate that particular user, okay, for that page. Like how you would log into Facebook or Instagram, social media, or even email, right? And if you wanted to bring in API, that's when you would be able to call the function that's going to bring in the API. And Google offers the open authentication API along with other companies, so you can also use there. So that way you don't have to make the user create the username and password every single time, and that will be cool. Okay. Okay. So this gives you a little bit more information about the decorator. You can find, different types of decorator documentation on their website. Then, so you would see that there. Then what we're going to do next is we are going to install Flask. And we are going to use Flask with Python 3. So we are going to do a pip 3. Okay. So you are going to do super user do pip3 install Flask. And then, like, if you take web development courses, right, the basic would be you need to keep yourself very organized when you're creating your pages for your site. So we want to make a folder, right? So this is just a common practice for your web app. You want to have a folder, and everything that you need to get that web app running is going to go inside it. You can also nest other folders in there for packages and things that you wanted to run for that app. So you would start with making a folder or a directory, okay? And then once you have that, you would be accessing that folder. You want to change into that directory and be able to do that. So um, let me switch here. Now, when you make this folder, it will be to your Pi home directory, okay, or your home Pi directory. I said the other way around. Hit 3, install Flask, and then let me close some of this and share screen on my Pi so you can see. So it tells me that the requirement is already satisfied, but if you haven't installed it before, you would then need to install it. So we already have Flask installed. Okay, for Python 3 distribution, we would use pip3. And then from my current directory, which is going to take me to, so when you make that folder, it's going to put it under your home folder and under the Pi by default. So if you prefer to put it into another location, you need to tell it, right, before you issue the make directory folder command, or make directory and then folder name. So I would do an mkdir, okay, and then web app. And you don't have to name it that way. You can specify how you wanted to name it. It's your app, right? So if I'm making a game app, I would give it, game app or whatever name that I want to call my game. So once we have the folder created, we would then change directory to that folder. Okay, and you see that highlighted in purple blue path there. Okay, so from there, what we can do is we are now in that folder. We are going to make a new file. Okay, directly in terminal, you don't have to call on Python. You can actually use Nano and then be able to navigate it by entering text editor. But without going into more Nano, I'm just going to use the idle that you're familiar with here. So you can go programming and then Python 3 idle. That's going to open up its shell. Then we are going to make a new file. Okay. And then we are going to enter our script. Okay. So we can say from Flask, we are going to import Flask. Okay. So that was going to bring in Flask from the library, and we are going to write an object. So create an object, and our object is going to be under the Flask superclass. That's a double underscore, by the way. Okay. And then if you took Python with me, this is where we end the first class, right after we learn class and also our GUI. Then we have a decorator, and we want to bring down our object name, and we are going to have it route. So that's going to use the slash. As in the URL, when you look at the URL, it would have, you know, let's say Microsoft.com slash and a certain page, right? So once the HTTP get and it gets a response from the server, it's gonna serve that first page, which is your index. And in that, what it's gonna do is at the end of your URL, you notice that there's a slash at the end, and any kind of extension to our website, the other pages, we would then follow that with slashes, right? Slash my page, slash my profile, and so on. So that's why we would use the slash in the route for the decorator. And it's gonna be, so it's gonna, we're gonna use that here. So if you have other page, you would then specify it like slash my page. Okay. And then after that, we would then define a function called index. Oops. I need to move my speaker out of the way a little bit. Okay. And so as a function, we would then need to indent and automatically do that for us. We are going to return, and we are going to say hello world. Okay. And the next part, we are going to do a conditional statement. So if your name, which is going to be from here, is going to be main, oops, uh, Python uses main like this. Oops. Can talk and type and lecture at the same time here. Okay, then we are going to run debug is true. Okay, and then your host is going to be 0, 0, 0, 0. Now, a little bit of networking here, right? This uses the IP version 4 address, which is what you normally see when you are looking at IP addresses, or also sometimes IP version 6, where it uses hexadecimal number. So when you see the octet, we call this the octet, that in each of the separation here is a byte, and combine their 4 bytes, so that total of 32 bytes in this address, then you I'm sorry, 32 bits in this address. So yeah, you would have, so this is an octet. So your address would be like 192.168.0.x, like .12 or .11 or .7, which is your internal address. That's your local address, local area network address. That address is not accessible outside of your home. Okay, that address is only internal to your home network or your local network. Um, Everything that we use, like from your mobile phone to your router, when you sign up for services, they give you a public address. And this public address is seen by other businesses, devices that connect you to it. So let's say that I'm on my phone and I'm visiting a website, right? That website has a public address, right? It's hosted by a public server. And with that, my phone or my smartphone or my computer, if I'm using my smartphone, it has a public address through its service provider. I use T-Mobile, so when I sign up for the service, they assign a public IP to my phone. Now, for your home use, your router has a public address, right? And everybody in your home use that one public address when they're accessing the internet. So let's think of it like a front gate to your house, right? Everybody has to pass through the front gate to go to the public street. Look, think of it that way. And in order for all the traffic to come back in, it has to go through your router, which is your gateway, and that router would have like its public IP. So that front gate is your home address, right? It's public. Everybody knows that's your home. But inside your house, you would have a private IP address. Now, for the functionality of this exercise, we are using private IP internally so that way you can see it from one device to another. But if in order to access it publicly, you have to put in its public IP, and its public IP is then going to be routed. So this is why when I said if you wanted to host your web services from home, you need to tell your service provider because they need to enable that service. So all the traffic would then go through your router and eventually your Raspberry Pi or your server system that you're hosting from. And you're going to get a lot more traffic than what you normally get in a regular home internet service, right? So that's why they would increase your service, pay or your bill and so on. Now, or you can hire a company that already have this established. So when you do a web hosting company, basically what you're doing is you're just leasing somebody's system that already have a public address, and then you put your page and all of that on there. So when other people visit it, they just access somebody's system that already have a public address, so that way they can see your content for your website. Okay, so right now inside, so let's say that I have a second Raspberry Pi. I would then, and it's hosting the server, then I would put its IP here. Okay, so the IP part, you want to put it in quotation mark when you code it, because it's gonna see it. It's gonna have to convert it, to translate it, because IP number is seen as string in programming. So you wanted to put in a quotation mark there. Okay. Any question? Okay. So after we have our file, then we're gonna go ahead and click Save As, and we want to navigate to the folder. Um, where is it? Web app. Okay, and we wanted to call this app.py because it's in Python, so we want to make sure that it's py. All right. So for I see some chat question. Could we make our private IP to have our internet and share it with family? Yes. So, um, so just like how you would use, tethering or, hotspot, right? Um, you can funnel everybody to that system as long as you give that person access. Okay. So, like for example, if I'm using my laptop, right? As a gateway, what I can do is I can have everybody connect to my laptop, and my laptop would then connect to a, a router, right? Like a hotspot, and then they can connect that way. Now, what happens is it's going to be very limited because let's think like, what if you have like 15 people that's staying there, and or 5 people and they have 5 devices each. And the more that you grow, everybody funnel back to that one device. It's gonna then become bottleneck, right? It's kind of like 5 lanes down to a single lane, and then and then that single lane is gonna determine whether they're gonna allow you through or not, right? Like there's a cop there saying, "Oh, you can go, you can go, you can go." Um, it's gonna become slower compared to if you do an ad hoc network where everybody is connecting as peers onto your router. Okay. So is it possible to use all one IP and not share it? Well, every single device has its own IP address. You cannot have a duplicate IP. on the same network. That's just the rule. So what you're going to have to say is that, the first IP is going to connect to the second IP, which connects to the router to be able to route it out. And that's the way it works. You cannot share IP. It will not allow you to set the same IP in your OS anyway, even if you force it. On the new OS, they don't allow that. But if you play with like Windows XP, it's going to tell you that there's a conflict of IP. So the rule in networking is you cannot have every device would have to have a unique IP. You cannot share IP. Some server would have multiple network interface card that has multiple IP, and so it's able to connect differently on the same system. Okay, just to answer your question. All right. So on the next, after you had done that, then you would go through. It gives you a little bit of explanation. You're welcome. So if you're interested in networking, I'm gonna plug. Take my CIS40A. You're gonna get hands-on with routers and switches, along with how to configure IP and subnet IPv4 and IPv6. Network is my core. I started my career doing technician work in network, and I became network administrator and eventually become system administrator. So that was when I started picking up a lot more, development and application and all of that. That was earlier in my career before I transitioned fully back into teaching. Um, so, yep, CIS40A. It's in the afternoon and it's actually on campus because we have to use some equipment, but networking can be very fun if you like it. Okay. All right. So, what else do I need? Oh, yeah, I gotta share screen with you here. Let's stop sharing on this side and share on this side. Okay. So after you have done the first part, then what you're going to do is you are going to add in pages to it. So when you visit a company website, you would have like the main page, and then after that, you might have like a tab for the page that says contact us, or order items here, or you can view products, you can view inventory, etc. Right? So for number 8, what you want to do is, here it shows you how you can do a new page, and then you basically just add the line of code where the first page route would be, um, and so then you're gonna save it. Okay. So what I did was I took a picture, or I added this so that way you know what it's supposed to look like. So after you add it, you just simply add it after hello world, and it will look like this. Okay. Now the address that you see is 127.0.0.1. In all systems, this address is defaulted as they call it a loopback address. So the system has to see itself in a network, right? It sees itself in a network to, so that way it can. So when you looking at a loopback address, it is just the system itself. So if my computer has an IP of 192.0.0 or 192.168.0.12, right? When you use 127.0.0.1, it's still that system. It's just another address that would refer to that system. So whenever you see the 127, it is a loopback address. And it is a way that I use this, I call it the boomerang or the loopback. So it comes back to its own self, its own identity in the network. And so um, it's a way that it calls home. So it sees itself as a host. So here, when you after you have saved your file, okay, as with the my page, the way that you navigate to it, if you put this into your URL on the Raspberry Pi, right, just open up your web browser and then type in 127.0.0.1, which is period, zero, period, right? And then colon 5000, right? This is a port number. The rule in URL, so the URL stuff is like www dot mywebsite.com. That's really for you human, right, to see. The computer system, it sees everything in IP addresses and port number. Okay, so when you visit a website, in the back it's connecting with IP addresses, right? It's not the URL with the text. Okay, the DNS, its job is to take that, convert it, give the IP address, and then and then the web server serve the page. So your computer only sees it at that. So what we're doing here is we're looking at our own system that has a my page and be able to load it up. So when you open that up, okay, you would see your name. And I hope that you put your name there so you would see it. Okay. And then inside your web app folder, you need to make another folder called templates. So your index page is going to be what most people see, the first thing they land on your site, right? And then the second page is going to be what you want to add to it. So most companies don't have their main page, and then after that they can add in additional pages. So as you move along, when you started adding more components to your website on your web server, you need to make sure that you keep organization. When I teach JavaScript, I always get on my students about that, right? When they write their scripts. So inside your web app folder, you're going to make another folder called templates. And this is when you can start building in your HTML code, right? For how you want your things to look and feel on your pages. Okay. And that way you can duplicate it. So what if I need to make 10 profiles for 10 employees on my website? Well, if I start making one template, I can start duplicating it and just copy and paste it over, modify a few things, and be able to add that, right? We should streamline the process when we do development, okay? So after you have your templates folder, then you are going to open up your idle or any text editor, and you can start program in HTML. And you should use HTML5, right? Because that's what's current now. So that way, you know, devices can open it up. You don't want to use the older version because it's just dated and it's just going to be ugly and not working for the newer device, the newer stuff. So, but it looks the same across the version for the basic. Okay. So here, basically in HTML, we would start with HTML. Okay, we say that this is an HTML file, and then you would have a body, or sometime you would have a title at the top. I normally would do a title at the top, but in this case, we have a body, which format the text to, on your headings to be part of the body. It's going to section it for that. And these are called tags, right? If you haven't done HTML classes. So when you open a tag, you got to close a tag. And to close a tag, you're going to use a slash right inside the bracket. Okay. So when you open one, you got to close it. When you open it, you got to close it. Okay. And here we have the first heading. And when you use heading, there are different levels. So H1 is bigger, H2 is smaller, and so on. And as you go to the higher heading number, you're going to see that your text would get smaller. And you want to use heading in that, so that way it's it's formatted for the right size, and also on accessibility level for the people who are using your website that's using screen reader and things like that. Those screen readers are designed to read sites with specific headings, right? When I write my documents, I have to use certain headings too. It helps students with screen reader read it a little bit better. Okay, so just organization is better as well. Okay, then you would save it as the index.html, and then you would go back to your app.py file, and you would modify the first line to add additional component from the library, which is render template. So as you go along each of the steps, it's very clear. I try to make it as clear as possible, right? So you will edit your the Python file, and then there are times that you're gonna edit your index file, okay, which is your HTML file. And then you are gonna change up your code again. And every time you change, you want to save it and then reload your page on the Raspberry Pi. You should see the difference. Okay. Okay. Any question? So cascade style sheets, when you look at like HTML, CSS courses, right? HTML always goes with CSS. It's a way that we can set up rules for how the browser would see the HTML content. So, um, and with that, we can add in functionality for our page, the look and feel for it, and so on. Okay. So after we have tested our file here, the index file with the updated information, we would then go into, um, sorry, this should be 2 dot, okay? Don't type 2 dot, 3 dots. So we would go up one level by doing cd space dot dot. So you were in templates, but you want to go back to web app folder. So you want to move back one folder by doing cd dot dot on terminal. And then we are going to make another folder next to the template folder called static. So there are two types of web pages, right? One that's going to be static, which just holds general information, text only. There's no interaction with that. When you go to that page, you can read stuff, and then that's it. And then you have other pages that will be more dynamic, where you can fill out forms, you can upload files, you can do a lot of different things. So you might have some static pages on your website, right? Like about the company or how to contact. And then you might have another page where it will be interactive. Okay. So after we make the static folder or directory, then we are going to make a new file using CSS. And here in the body, you want your page to have red and yellow, but you can use your own color of your choice. Okay, just think about the contrast of color, how easy it is for people to see when you use color. And with HTML, you can use color name, or you can use the hex color. Okay, so you can do like red, which is default to the red. And so the background is going to be red, and then your text is going to be yellow. Okay. And then in the next part, you also going to add, or you're going to modify the index HTML, the first one, and then you are going to change it up to have a reference for the link here. So you're going to link the static, the through the static folder and the style.css, okay, which is this. Okay, so with that, what it's going to do is going to load the CSS file, and then it's going to make sure that it's going to show red and yellow on that page. Okay, so once you modify that, then it's going to update the index, and then you're going to test it by checking the browser. So it's going to look like this. So on your URL, you do 127.0.0.1, right? Colon 5000, that's the port. Now that's an uncommon port number. You want to use uncommon one to test. So that way it's not affiliated with other services. But most of the time when you see companies, they would control, regulate the port. And that helps us with how we control the traffic in and out with firewall too. So when you update the index with the reference, you're going to reference the static page. So it's going to load the content of the static, the CSS rules, and it's going to show my website in color. Okay. Okay, so the structure of your folder would be like this. And then for the next part after that, you would then do dynamic content. Okay. So far we have a static page, which is kind of boring. We would then need to do something that the user can enter. Okay. So you would then go back to your .py file, your app file, and then you would modify it by adding this on. Okay. So you're going to add another decorator, another function with that. So when the user put their name on the URL, it's going to show their name on the page. Okay. So some of these steps you have to go back and forth on editing some of these files or creating new file. And then every time that you do that, you want to save and then reload the page. So after I have changed up my script and then also add in a page.html, I can visit the URL again, and if I put in my name on it, it should show my name. Okay, so in this example, it shows you Paul, and on the next one, you should see the picture. It says hello, Paul. So it should say hello and then your name if you put it. Okay. And then we would then continue to edit our index HTML. Okay. And so for this one, you are going to link the first page to the second page. Okay, so here you would have a link there. And you would do that using href for reference link. And you can play more with it if you're good at, HTML, CSS. You can find a lot of tutorials. You can play with it. You can change color. You can add your own pictures. So, make like your own profile and so on. So once you have it ready, okay, then you're gonna tell somebody at your house to, or you can use another computer or open up a browser and then type in your actual IP, not 127. So let's say if I have like 192.168.0. Let's say 21 is the IP, then you just type in the IP and then colon 5000 and see if it actually loads the page on the person that's on the same network as you. It should be, okay? If everything is set up properly, so you should see your index page and, and you can tell them to put in their name to test it and so on. So you can test it on your local network, okay, by using your IP address of the Pi, okay, where that file is stored or the folder is stored. Okay. So when we're done, we would then take a picture of the page, okay, and then you can upload that one picture is okay. If you want to take multiple, sure, that's fine. Or if you want screenshot, you know how to do screenshot, you can. You can use your phone to take a picture, that's okay. Okay, so today we tackle two. First was Sonic Pi, which I spent a little bit more time on because it's a little different. And then this one, we would use HTML, CSS with Python so you can see how that's done and then be able to host it with your Raspberry Pi. So people that are on the same network as you, they should be able to see it. Don't use the 127 like what I said, use the 192 address of your Raspberry Pi, which you can also find by clicking on your VNC information or your you can click on your little wireless symbol. It should also tell you what kind of network you're connecting to, and then or you can do ifconfig in terminal to get your inet address. Okay, it should be an octet. Any question? All right, so I'll be on for about 10, 15, 20 minutes or so. I think I have a student made an appointment at 4:30, so I will drop off before 4:30. Let me stop recording. I'm going to be